Okay, solving with the another example that is called as a 1.7. 1.7 is called as a theoretical type or concept type of question, which is asking us normal properties indirectly of electric field. An electrostatic field line is continuous curve, that is a field line cannot have a sudden breaks, and why not? Because we are aware about there are some of the properties of electric field. For the positive charge, we are saying that this electric field lines are outside, and for the negative charges its electric field lines are inside. Whenever we have a subset of two charges, let's say one is positive and another is negative, the electric field lines are directly passing from positive to negative, but there is no break, it must be continuous. We are putting this formula E is equals to kq by r square. It means that r distance up to that distance, let's say I'm just mentioning plus q to minus q, or distance is r, it means that is electric field is only possible or reaching to the only this much distance. If I am putting that only discrete lines, means up to this point lines, it means that at this point its electric field will be 0. If I am putting that plus q charge, if I am putting that it is reaching up to this part and another field line I am showing that, so it contains that meaning plus q charges electric field line is reaching over here, and that after this point it is 0. The another field line which has been shown over here, it is not of this charge but it might be of another charge. So we can say that electric static field lines is continuous curve and must not break at any point. Another important aspect is called as electric field lines never intersect, because whenever electric field lines are intersecting, let's say I have a plus q charge, its electric field lines are outside, and let's say I have another part that is called as a plus q, it is also outside. If they are intersecting at this point, its electric field will be 0. So whenever you are solving or whenever you are discussing about electric field lines, you must aware about electric field lines must reach to the part which cannot be 0. Good example that is called as our 1.8. We have a two charges of a made up a system, 3 microcoulombs, and another is called as a QB is minus 3 microcoulombs. Whenever we have a two charges, we have a something in our mind is that there might be the possibility of electric dipole moment. Both the charges are located at a 20 centimeter apart in the vacuum. And what is the electric field at its midpoint? I am drawing that another minus q plus q. You can place these points anywhere together. Both are 20 centimeter apart. This is the midpoint. From midpoint to the distance is called as a 10 centimeter. Same is the course for the another one. It is called as a 10 centimeter. I am putting this part as a point. This is the B point. I am using that electric field for the A. So E of A would be KQA divided by OA, its midpoints part, that is called as a OS square. I am mentioning OA is called as a 0.1 meter. Same is the course OB equals to 0.1 meter. So I can have is equals to 9 cross 10 to the power 9. Value of A is equals to 3 cross 10 to the power minus 6, and OA it is 0.1 square. I can have electric field of EA for the first positive charge, A charge, 10 to the power minus 6. Sorry, it would be a plus 6 because we have a plus 9 and minus 6. It is Newton per coulomb. This is for the EA, means for the A. Let's say I'm finding it out for the another one. It is for the OB. We can have E of B, K, QB, 0.1, it's a square, and I am putting negative sign. I am mentioning that negative sign indicates electric field opposite to its nature. Means for the dipole, electric field lines are passing from the negative to positive. That is why I am putting negative sign. Or you can also use another type of concept part. because electric field minus to the center part, it is going against the conventional line or against the origin. So we can have E of B is equals to minus 9 cross 10 to the power minus 9 minus 3 cross 10 to the power minus 6 divided by 0.1 square. So electric field for the B part is equals to 27 cross 10 to the power plus 6 Newton per coulomb. Here we want to find it out net electric field. So I can have net electric field E is equals to call as a EA plus AB is equals to 27 plus 27, power is the same, so we can have a 54 10 to the power 6 Newton per coulomb. It is electric field of this part. So this is called as a 1.8 example. Here we have found it out. It's a electric field for the positive and a negative charge, and it is net. It is 54 cross 10 to the power 6. Moving forward, another example that is called as example number 1.9. It is one of the smart type of examples. Why I am using this a smart type of example? Because if you read this term, it will give you some of the glimpse. A is equals to 0 0 minus 15, B is called as a 0 0 plus 15 centimeter. Charges are plus 2.5 10 to the power minus 7 and the QB equals to minus 2.5 10 to the power minus 7 coulomb. As we have discussed in 1.8, whenever we have a positive charge, negative charge, opposite in polarity, and if you will find it out its magnitude, it is equal in proportion. So there are the fulfilling conditions of a dipole. Distance from the centers. Here we have a minus 15 and plus 15, so we will just draw this figure and just see that whether it is fulfilling the another condition of a dipole or not. You can see that it is dealing with the z-axis only because x and y-axis in the both the parts will be 0. I am naming it as a z and extending this one as a z dash. This would be x of no use and this would be the y of no use. This is the positive part of a z and this would be the negative part of it. So I can just use that 0 0 and minus 15 centimeters, and this would be 0 0 and plus 15 centimeters. But the position of a charge that is called as a QA over here and QB over here, because we have mentioned that charge A is minus 15. Be careful, we are generally habitual to put positive over here and negative over here, but same is true, but our charge of A is given as a minus 15, which is in a negative proportion, which is in a negative part of a z-axis. Now we have been given two tasks. What are the total charge or net charge? An electric dipole moment of this system. If this question can be asked for the MCQ, I can directly say that both are fulfilling the condition of a dipole moment, so net charge will be 0. But for the examples, we have to just show it. So Q is equals to QA plus QB. One would be 2.5 10 to the power minus 7 coulomb positive, and another is called as a minus 2.5 10 to the power minus 7. So net charge will be 0. Now I want to find it out dipole moment. For dipole moment, our formula is called as a 2AQ. So we can say that this is 15, this is minus 15. So net distance would be them is called as a maximum minus minimum. So that is called as a 2 into 15 centimeter. So I can just say that 0.15 meter, because I'm mentioning that D is equals to 2A is equals to 0.15 multiplied by 2 is a 0.3 meters. I'm changing its units. Q, that is called as a Q of A. So I can have a P is equals to 0.3 meter and value of A is a 2.5 cross 10 to the power minus 7. So I can get dipole moment is equals to 0.75 cross 10 to the power minus 7. Unit is called as a coulomb into meter. I have shown you one of the precaution whenever you are putting the dipole of a P, because it is called as a coulomb into meter. Mention or be careful, put a dot in between C and M. Moving to the next example, that is called as a 1.10. 1.10 is giving us another reminder, which is giving us that whenever we have a value that is called as an electric dipole of a dipole moment 5 cross 10 to the power 4 Newton per Coulomb, and its angle between them is called as a find out torque, electric dipole moment aligned at the angle, that is called as a theta. Whenever you are not sure about where electric field and where electric dipole moment is there, show or have a vision over its units. Your dipole moment having unit coulomb into meter, so I'm mentioning that P is equals to 4 cross 10 to the power 9 coulomb into meter, and our electric field which is over here, that is 5 10 to the power 4 Newton per Coulomb. Theta is given, which is 30 degree. We have to find it out torque. First of all, torque tau is equals to P cross E. We want to open this bracket or vector part, so we can have a Pe sin theta, torque tau. So torque tau is equals to 4 cross 10 to the power minus 9, 5 cross 10 to the power 4 sine 30 is called as a 1 by 2. So we can have a 10 to the power minus 5, so it is called as a 10 to the power minus 4, unit of a joule, torque's unit is called as a joule. So we can have a torque tau is equals to 10 to the power minus 4 joules. 1.11 in the 1.11 we have been given that a polythene piece rubbed with the wool is found to have a negative charge. It is called as a 3 cross 10 to the power minus 7 coulombs. Estimate the number of electrons transferred from which to which. Always our charges, whenever negative charge is there, it is having nature, it is obviously attracted toward the positive charge. So minus q is always attracted toward the positive charge, even though both are having the same magnitude. I can just use that part. Q is equals to minus 3 cross 10 to the power minus 7 coulomb. We have to find it out a number. So n would be what? We have seen that ionization value, its value is called as a plus or minus Ne. So n is equals to Q by electron. We are aware about that electron's charge is called as a 1.6 cross 10 to the power minus 19 coulomb. Our Q is minus 3 10 to the power minus 7. Our electron is a 1.6 cross 10 to the power minus 19. So our number would be 1.875 minus 19 and plus minus 7, that would be plus 12. Number does not contain any type of unit, so it is unitless quantity. So this much amount of number of negative charge will shift towards the positive charge. Now next one is a good one. It is giving you that examples can be asked by different manners. 1.12 we have been given that two charges are there, both are separated by the distance of a 50 centimeter, and if we will find it out what amount of a force they are exerting, we can see that okay, what would be the force, and next question can be there, and it is showing is us what is the force of repulsion if each sphere is a charge double above the moment and distance would be halved. Okay, that is the second part. So first of all we will find it out, and they will give us the first part. Very first part is giving us that, let's say F would be kq square by r square, because I have mentioned that both these charges are equal. F equals to 9 cross 10 to the power 9, and that is 6.5 cross 10 to the power minus 7 square divided by distance between them, which is called as a 50 centimeter. I'm converting in the term of a meter, 0.5, it's a square. So I can find it out my amount of a force. It is a 1.521 cross 10 to the power minus 2 newtons. This is the first task. Second task, be careful whenever such type of examples are there, when your charges are doubled, halved, tripled or quartered, amount of force we have to find it out and compare with the previous one. Each sphere is a charge to the double the above amount. So let's say I'm just mentioning that a QA dash equals to 2 times Q of A. I can say that Q. And the second one, QB dash is equals to 2 times Q of B. It is a twice times of Q. And the distance R dash equals to R by 2. So my new force is called as F dash, KQA dash, QB dash, R dash is square. Putting those values, twice times Q, twice times Q, I can have a 4 times Q square. R dash is called as R square by 4. So going in the numerator, that would be 16 times KQ square by R square. So my F dash is giving us 16 times F. So you can say that F dash equals to 16 multiplied by 1.521 10 to the power minus 2 amount of newtons. So after comparing this one, only the thing you have to place is that values of F from the previous one. Then your task would be quite easier one. Next such type of a few 4 or 5 examples are there. You have a charges A and you have a charges B, both are brought in contact with another one, and you have to find it out what amount of a charge of a next one would be there with us. First of all, we have to take those datas of the previous example, that is called as a 12th number. So we have the values of a charges QA, QB, which is giving us that 6.5 cross 10 to the power minus 7. Distance is again same, and we have to just take that after brought in contact with each other, what amount of forces we will have. We have a first of all A and B, both are separated by the distance, that is called as a 50 centimeter. This is the story of example number 12. Now we have another charge which is chargeless. I'm mentioning with another color, that is called as a QC is equals to chargeless. First of all, we have been given that be careful which one is brought in contact with which one, and it will give you the proper simplification. Thus third sphere of a same size as A and B, but it is uncharged, means chargeless, is brought in contact with the first one, means A. I have A, which is QA, and it has been brought in contact with the C, it is chargeless. In the classroom, I have told you that whenever you have a charge which is brought in contact with a charge less, it is losing its charge and another one is gaining its charge. So be careful whenever you are sharing your ideas with another one. Your ideas might be either lost or maybe gained if someone is having their charges. QA dash, or I can just simply that the Q dash is equals to QA and QC divided by 2. QA is holding that charge 6.5 cross 10 to the power minus 7. Sorry, and this is plus 1. C is chargeless, divided by 2. I can have 3.25 cross 10 to the power minus 7 coulombs. This is called as a Q dash, which is new charge of A and C. After that, I have another thing to find it out. Now C is brought in contact with the second one, means now C, it is called as a Q dash, new charge of it. This is the story of previous one, which is chargeless previously, now it is having new charge. It is brought in contact with the B, so this is called as a QB. So I can have a new charge Q double dash equals to QB Q dash divided by 2. We are aware that Q dash is a new charge which is a 3.25 10 to the power minus 7 coulombs. So Q double dash is equals to QB, which is holding 6.5 10 to the power minus 7 plus 3.25 10 to the power minus 7 divided by 2. So we can have a 9.75 10 to the power minus 7 divided by 2. So we can have approximate Q double dash equals to 4.8 10 to the power minus 7 coulombs. And this is the story of new charges of BNC. But we have to find it out new force. Let's see. Again, I have A, I have B, it's holding that charge Q dash, it is holding that charge Q double dash, distance between them is called as a 0.5 meters. So I'm solving this one for you. I have a new force, F is equals to KQ dash Q double dash upon distance, that would be 0.5 square. F is equals to our previous value of Q dash is 3.25 10 to the power minus 7 into 9.75 10 to the power minus 7, 9 cross 10 to the power 9 divided by 0.5 its square. So it is giving you the answer of F double dash is equals to 5.7 cross 10 to the power minus 3 newtons. Let's compare with the example number 12. In example number 12, we have the amount of force which was 1.521 10 to the power minus 2, and after bringing them with the contact with the chargeless, we can have this one 5.7 10 to the power minus 3. So obvious there would be a difference of 5.7 cross 10 to the power minus 3 newtons. Moving to the another example, that is called as a 1.14. Okay, that is different thing, that we are going somehow faster compared to the usual class, because right now we are aware that it is called as an online class, so we don't have other type of things to do, so we can directly focus on all those things which are directly given to us. Now in example number 14, we can see that we have been given that there are two different things. Very first part is figure. In regular classroom, we have discussed whenever we have a such type of arrangement, when we have a positive charge, negative charge, one charge is going down or called as a free fall, it is giving us a reminder of our 11th science, where our formula of a motion or mechanics, that is called as a D equals to V naught T plus 1 half AT square. Though it is called as a free fall, V0 is 0, so we can have a 2D by A is equals to T. But in this chapter we have another part, F equals to MA and F equals to QE. So we can have a T is equals to under a root of 2D A, that is replaced by another thing that is called as A QE, and this is called as a M. So this is called as a Mentos Khao and the Maki Batti Jalao example. But only when we are having given charges which are falling freely under the influence of there are another external force and attraction, we will use time by such method. D is called as a distance between such type of charges. M is called as masses. If we are talking about free fall of a proton, we will use mass of proton. Charge or electron will be same, it is 1.6 cross 10 to the power minus 19 coulombs. Electric field will be assigned to you. But in this example, the cases might be different, because in this example they haven't asked us such type of thing. They have just only asked us that we have to see that what is the polarity of three charges, plus charge, minus charge, and third one. Here we can obviously see that first is extended or attracted towards the positive. Second one is also having the trajectory which is towards the positive charge. So we can say that 1 and 2 are attracted toward the positive charge, so they are negative charges. Then the third one having trajectory which is towards the negative part, we can say that it is called as a positive charge. That is quite simple one. But another thing they have asked us is called as a charge to mass ratio. Whenever charge to mass ratio is there, it is giving us another reminder. In future, there are two places where we will discuss about the charge to mass ratio. It's called the gyro-magnetic ratio. It's having that value Q by 2 me, and another is called as a dual nature of particle, where we will discuss about the charge to mass ratio. So we have a two charges, one is positive, another is negative, that is called as a Q by me, and next one is called as a Q by mass of proton, where Q is fulfilling that electron and me is called as a mass of electron, Q is called as electron mass of proton. Placing these values, we will have the Q 1.6 cross 10 to the power minus 19, and mass of electron is called as a 9.1 cross 10 to the power minus 31. Same is the value of a Q, that is called as a 1.6 cross 10 to the power minus 19 coulombs, and mass of a proton is called as a 1.67 cross 10 to the power minus 27, which may lead to these values where our charge Q by me giving us the value 0.17 cross 10 to the power 12. Its unit is called as a coulomb per kilograms, whereas Q by mp leads towards the value that is called as a 10 to the power 8 coulomb per kilogram.